Hi everyone. Today we are going to discuss about load balancing services in Azure. The very first one, that is Azure Load Balancer. We are going to see more details about Azure Load Balancer. Before that, the last week we have discussed about the topic communication of Azure resources with internet. So in this, we have covered Azure Public IP, Azure NAT Gateway, as well as we left out load balancer, which means using the load balancer also we can connect to internet. Okay, that feature also load balancer will do. Okay, so before getting to the load balancer, the the first one we should understand about OSI layers. Okay, so what is OSI layers? When the system want to connect any of the network, the traffic the the traffic of the network will go like packets. So just this is your system and this is the network, and this is the system. When system want to connect to their network, which means the data will be transferred over the cable like packets, small kind of packets, network packets. Okay, so the data will be transferring from source to destinations to source like this packet wise. Okay, so to transfer this data, there are seven types of OSI layers are there. Using this way only, the communication will happen from source to destination. This is source and this is destination. Okay, the standard method, most of the world, they used to follow the fourth of layer, that is transport layer. This is the common one and frequently using TCP UDP protocols. So the data is transferring using some protocols, TCP or UDP protocol. Using the protocol, the data will be carried out from source to destination. Okay, so why I am explaining this one, the layer 4, you can see the layer 4 is transport layer, transmit the data using transmission protocol TCP and UDP. The load balancer, we are going to discuss about load balancer. The load balancer backend functionality is depends on this transport layer. Okay, so that's what I just explained about the OSI layers. The first one, physical data link layer, network layer, transport layer, session layer, presentation layer, and then application layer. Okay, the next two topic we discuss about application layer one. Okay, so now we will see more details about load balancer. So fine. So first of all, what is a load balancer? So the naming itself we can understand. Load balancer means something balancing the traffic. Traffic in the sense the incoming request. Let's take an example. This is the system. I mean, this is my server, and sorry, and the database or something like Flipkart application is configured here. The people are simultaneously accessing the Flipkart site parallelly. For example, 100 users. Okay, so suddenly the users are gradually increasing up to 1,000 users, but we have designed this server for only 100 users. So what will happen at that time? the server will go down and user will get timed out error or 404 error, something like that. So there will be a very big product loss as well as business loss also. So to overcome this issue, then Azure brought concept is load balancing concept. So what load balancing will do, generally just group, it will group the virtual machines, and that load will be equally transferred to the all the virtual machine. For example, if the first 100 users, it will transfer to first server, next 100 users to next server, after that next, like that, equally distribute the load. Okay, so using the load balancing services, we can override load balancer. Using the load balancer, we can overcome our product issues and make our applications into high availability as well as faster reliability, also faster response. Okay, so yeah, and this load balancer, as I said, act as layer 4, which means TCP UDP based protocol. Okay, so we'll see now professional diagram about load balancer. Okay, I'm going to design a diagram. So just assume that this is my network VNet. Inside the VNet, I'll just place some subnet. Just assume that subnet A. Here I will place the virtual machines like this. Okay, so the load balancer will be located here. Okay, so the traffic will come from outside of the internet, that we can somewhere we can give it as this is internet. Okay, so the request, incoming request, will come from internet to load balancer. Okay, this is incoming request. So the load balancer will find out what request came and where we have to transfer the request. Okay, so for that we need to configure here, we need to configure load balancer rule. Okay, just give it as rule. Okay, so we need to define the rule because load balancer doesn't understand where to transfer and what to transfer, so we need to define the rule. Okay, so the load balancer rule will work under 5 tuple concept. Okay, the load balancer will work under 5 tuple concept, which means source IP, source destination, sorry, source IP, source protocol, and destination IP, destination protocol, call. One more is there, port, I guess. What is that? Source IP, source port, destination IP, protocol type. Okay, sorry, I said wrongly. Source IP, source port, destination IP, destination port, and protocol type. These are the five tuple. Okay, has algorithm. Five tuple has algorithm. So the load balancer will function on this five tuple concept. Okay, so we need to define the rule here. So based on the rule, that traffic will be routed to backend equally. For example, I am just creating an application from the backend servers. So the web application port would be HTTPS or HTTP. So I will just define the rule port 80, port 80, HTTP and HTTPS. So the load balancer will find out the rules, and based on the rule, the traffic will equally distributed to backend servers. Okay, 80, 80, 80. Okay, so in load balancer, the first part, this load balancer first part is called as front end IP. Front end. Okay, load balancer will assign with one public IP so that it can connect to the internet. Okay, so that is why the first part is called as front end IP, and the servers list, the backend, this called as backend pool. Okay, load balancer backend pool. And when we place the virtual machines in the backend, make sure the virtual machine must be part of the availability set. Otherwise, the backend pool concept will not work out. So, backend pool availability set is required. So just remember that. I'll just make it here AV set. So we need to create one AV set. Under the AV set, we have to place the VMs, group the VMs, then place the VM to Azure load balancer backend pool. Okay, so this is what we are going to set up now. So any doubt in this Azure load balancer is a very important one, and frequently interview also they will ask. You have to handy informations about load balancer. So any doubt in this? Are we good to create the load balancer? I guess yes. Okay, so now you can say this load balancer having front end IP, which means public IP. Okay, so this load balancer is public load balancer. Okay, so the load balancer have two types. One is private and other one is public. Okay, so this public is completely internet faced. This private is completely using for internal purpose, which means here how the requests are incoming requests are coming from outside the, I mean, over the internet, then the public load balancer would be required. At the same time, the user already part of Azure network. Okay, so just assume that the user also part of same network, he want to access this application. Okay, so then that case we can define private load balancer, because within the network there is no outside internet is required. So using private load balancer and the rule, the user can communicate it. Okay, this is the simple definition of private and public load balancer. Okay, so any doubt in this about load balancer? I guess no doubt. So we'll go to uh, we'll create the load balancer now, and then one by one we will proceed it. First we need one network. Okay, so just go to my Azure portal, go to network. I have already one network that is created for VNet purpose. Okay, so just in the global search load balancer. Okay, so load balancer. So just create a load balancer. Choose your subscription and resource group and give it as LB-001. Whenever you create a load balancer in the project, you have to give some meaningful name, and the naming convention will be given by manager or some SOP from the project. Okay, so we cannot give any name. There is a naming standard from the project. So I'm just giving as LB and SKU types. Again, there are some types of load balancer. I mean SKU types. Whether we need this load balancer for standard purpose or basic purpose or gateway purpose. So standard means this is the recommended one, which will have required functionalities and required parameters in the load balancer. When you go with the basics, some of the features will not be available. So that is why they have given a SKUs, three different types. Based on our requirement, we can choose the load balancer. Okay, and then type of the load balancer, we need a public or internal purpose. So we are not internal users, so I'm just going with a public load balancer. And tier of the load balancer, we need a regional based or global based load balancer. So regional means within a single region. If we need across multiple region, then we can go with global load balancer. Okay, so I'm choosing with the regional. And the next step is front end IP configuration. In the diagram you see, the very first, while creating the load balancer, the front end IP is required. So the front end IP is public IP, which is which will be required to connect to the internet, so that the incoming request will come over the internet. Okay, so this is public load balancer, so it is public faced. We need to create it now. Okay, so I'll just create a front end IP. So front end IP means, as I said, it's a public IP. We need to give something naming as load balancer sir hyphen pip, and can associate this load balancer. I'll create one new IP for this. So lb hyphen f front end hyphen IP. Okay, so just click and add it. So the front end IP is configured. Next thing, backend pool. We need to add the backend pool, which means you see in the diagram. Oh shit. We need to add the backend pool. As of now, we did not created any of the virtual machines in the backend. So I'm just giving as empty only. After creations, we will give it. Okay. After this, inbound rule. So I said, right, rule we need to define. So whatever the incoming request that come to load balancer, we need to define the rule which can be transferred, which can be routed to the backend, respective backend servers. So that we will create it after load balancer deployment success. Okay. So outbound rule. So outbound rule is required when this backend server need to communicate to the internet. So suppose I need internet access from the backend pool, means we can define some outbound rules that also we'll see later. Okay. Outbound rule. So I'm not giving anything now. So next to tags and click review. Fine. Creating. So it's creating now. So now we created load balancer. It will take some time. So meantime, what else is required? What other components required? So load balancer we are creating now. So we'll create a backend pool now so that we can attach with this load balancer. Okay. So for this load balancer, I need one backend pool. In the backend pool, I need to place the VM. So to place the VM, I need availability set. Okay. So why availability set is required means, so last session, I mean, the second week, we have discussed about availability set. So availability set concept is fall domain as well as updated domain. When one server get rebooted and the other server will be up and running. Okay. And when other server is rebooted, one more server will be up and running for high availability purpose. Okay. If the servers are in availability set, the servers will be keep running, the application will be keep running. But who will access the application? The applications can be accessed by the outside users over the internet. Okay. So when outside users want to access, there is some mechanism required to route the traffic. So that is that purpose the load balancer came to the picture. Okay. So when we want to place any of the virtual machine under load balancer, the virtual machine must be part of AV set, availability set. So this is very important. So keep remember in the mind. So now I'm going to create one AV set. Under the after AV set, I will create two virtual machines. Okay. So load balancer is deployed successfully. Let it be. I'm going to create uh, one availability set. I will give a default options only. I'm not going to give anything. So any doubt guys about load balancer? And after the load balancer, the another topic would be application gateway. Both will be very similar. You don't get confusion. Okay. Just make it a note from your side about load balancer so that you will not get confusion when we do a test hands-on in application gateway. Okay. So AV set is created. So quickly I'm going to create a virtual machine. Availability set. Here you see availability option is availability set, and we need to choose the respective availability set. During the configuration itself, we need to define the availability set. If you forgot, when you deploy a machine, if you forgot the AV set, then you have to recreate the entire virtual machine once again. So when you do, you have to very careful and do it. Okay. So it's user. After the virtual machine creation, I'm going to do one more action in the virtual machine that I'll show in it. One load balancer. So the two virtual machines I'm going to create. So one I am assigning with a public IP because to take RDP it's required. So I'm just assigning one public IP and go here. So quickly deploy it. Okay. First machine is going to create. So in the diagram I discussed about the traffic routing to the backend pool. So we are just creating the virtual machine. I'm going to run web services. I mean, I'm going to create one simple Microsoft web-based application, which means like www dot some microsoft.com, something like that. Okay, one application, web-related application, I'm going to create inside the virtual machine. Okay, so web application is nothing in the Microsoft server, Windows server. They have a default feature that is IIS, Internet Information Services. Okay, so when we enable this IIS, the system, the virtual machine will be converted like one application server. When we enable this IIS, the port the port A0 will be enabled and we can use the machine for application related. So after enable IIS, we can get http slash localhost port 80. This URL, I mean this is the application URL, localhost URL will be triggered, will be enabled after we enable this IIS. So this IIS mainly using for application, web applications related. Okay, that we are going to configure in the virtual machine. So why I'm configuring means in the load balancer we are going to test it whether the routing happening properly or not. Our routing rule would be 80. Okay, so the 80 means for HTTP request. So the 8023 machines, if we placed in the backend, the traffic incoming request equally distribute the traffic 80 traffic to backend, so that from the user perspective, sorry, from the users we can access this localhost website here, http localhost 8080. Over the internet we can access the application, this localhost application inside the machine using the port. So multiple machines, if it is there, the load balancer will equally distribute the load. That is the concept, that is the load balancer concept we discussing. Okay, so we will create two machines and we'll test it whether the load is equally distributing. The load means HTTP, this 80 port 80 load, that is equally distributing or not, that we are going to see. Okay, so fine. Okay, the first machine is deployed. Parallelly, I will create a one more machine so that we can test the load. One machine is this there means how we can test it, we cannot test it. So that's the purpose. I will create multiple VMs, I mean VM2 Sorry, availability option is IV. So for this VM, I'm not assigning RDP port because one machine is there. With that, I will take RDP directly. So I don't want other machine also port 3389. That is placing in the same public IP, none, basic rules. So let it create. Meantime, the first server I will take RDP and I will do the configuration. So we have created a backend pool. I mean, we have created these servers, two servers, and then AV set we created. After creation successfully, we will add the server in backend pool in the load balancer. Then we'll create the respective rules. Okay, so let server come up. Okay, the server come up now. Let's wait to load the server. There is some PowerShell script also to enable the IaaS services. We'll do manual here first. Okay, so first you have to go to start menu and here you search server manager. The first one, server manager. So go here. The first one, add rules and features. So just click next. Again, rule based feature. Click next. Next. Here in the server roles, we need to enable web servers. Web server IaaS. You see, IaaS means we are converting the machine, normal virtual machines, into web server machine. Okay, so add the feature, click next, 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 install. So it will take few minutes. So we are configuring this IaaS web services in the VM1. Okay, so the same thing we need to do in the VM2. So let's see whether VM2 is created. Okay, the VM2 is created and I did not assign a public IP for the VM2 because I have already one machine with the public faced. So I'm just directly taking RDP with private IP. So go to the virtual machine. Inside the virtual machine, need to take RDP MSDC. Here, try the machine RDP. AG user. So we'll see what is the load balancer front end IP. Okay, so we created a load balancer with the front end IP. So just open the load balancer and you see the overview of the load balancer. There is no backend pool, it is 0, and there is no load balancing rule we configured. Okay, and yeah, and just go to the front end IP configuration. So you see this is the front end IP, load balancer IP, which is triggered. So in the diagram, I'll just paste it, front end IP. Okay. So, so to monitor this backend servers, I mean backend pool, whether servers are healthy or unhealthy, or the request is going properly or not, for that, I mean to monitor that the traffic, there is a component that we need to create, that is, just assume that here it will be, that is health probe. Okay, health probe. So which will monitor the backend servers healthy or not and all. Okay, so while configuring we'll get to know that one. Okay, so go back to my server, and the second server I'm able to RDP. So quickly go ahead and install the rules. Next, sorry, forgot to server. So let it be. You see in the VM1, the rule is configured, installed. The web server is installed. So just close this. What you do, go to your Microsoft Edge. Here in the browser, you type http colon double backslash localhost localhost something error is coming. Yeah, you see when I hit this local host, there is a web service, internet information services web page has come. Okay, this is inside the virtual machine. I mean, assume that this is the one web application, I mean HTML based, browser based one web application. This page we need to get it over the public I mean using the load balancer IP in the internet. We have to get the same page in the internet. Okay, that is our motto. So now in the start menu, search IIS, we will get Internet Information Service Manager. Okay, open this one. You can see the machine is converted into web server, and you are getting the IES manager, web manager, to control and to do the changes here. So okay, so you see the VM1, this is our VM1 which is converted into web server. So you can just extract it, and you see what is the website that is running inside the server. Default website, which is port 80. Okay, that is running inside this virtual machine. Default website. Earlier it was just a virtual machine. We just converted the machine into web server. After that, it is running by default websites. Okay, So just right click of this website, click on Explorer. So why I'm opening this one, we need to differentiate which is VM1 and which is VM2 traffic. So that is why we need to edit this web page. You see the web page came, right, the website came, but we need to edit, just to edit this page so that we can identify which incoming requests are coming. Okay, so choose this PNG image, just double click it, it will open in the paint. So here I will just highlight it. This is the VM1 website. Okay, so I will save the changes, saved it. So the image is we edited, go back to web pages again, just refresh it. You see we are getting VM1 website page. Okay, there are two ways to reach out the website. One is through directly localhost name. If you give localhost, you will get the web page. Another one is IP address. Okay, what is the IP address? 10.1.0.0. So if you give directly IP address, we'll get the same page only. You see the same page is coming. So we can reach out any of the website using IP address as well as FQDN, means name, name to IP to name. Two transfers are there. Okay. So the VM1 configuration is completed now, entirely completed. So we'll see the VM2 status. Okay, VM2, it is completed. So I will just go to IIS. I'll do the same setup in the VM2 as well. See, same default website also running in the VM2 because we have enabled the server, enable the WBS, sorry, web server. So this server I'm making its VM2 website. Save these changes. Same, go to browser. Microsoft Edge. You see when I type localhost, by default it came website page. Okay, so now the backend, I mean the servers we created VM1 and VM2, and we enable these web services in both the machines. Okay, now we need to add this machine in load balancer. Okay, so for that, go to my load balancer, just search load balancer. This is my load balancer. Just click here, go to backend pools. Okay, so here we are going to add our virtual machine. So just click add. Here give the backend pool name something, backend pool. What is the virtual network? The virtual machines are present. So I choose my virtual machine, and here you are going to add the backend pool NIC card or IP addresses. So anything is fine, both are same only. So I'll just give it as NIC and click here, add. You see two virtual machines under the same network that is available. What I will do, I will add the one machine, the another one machine I will show in different method how to add in load balancer. Okay. So one machine I have added, just save the changes. Okay. One more machine is left. I will add through different way. So let it complete. So any doubt till now, guys? So you feel it is literally confusing, but keep remember. Okay, this is very simple only. You see the VM1 is I have added. I need to add the VM2. That's right. Okay, so for that, to add the VM2, so I will add from virtual machines options. Okay, go to virtual machines. VM1 we have already added. So VM2, here go to networking. Here in the networking you see inbound port rule, outbound port rule, application security group, load balancing. Here click on the load balancer and add a load balancing. Choose the load balancer, select the load balancer here, create a backend pool. I have already created, so I'm using existing one. So this is my backend pool name. Backend pool is the backend name. Save this changes. Okay. So if you did not enable the availability set, then the server cannot be placed in load balancer. Now in the virtual machine options itself, you can search AV availability and scaling. Click on that and you can see which availability set is configured. You see availability set is configured for the VM, and this VM is placed under fault domain 1 and updated domain 1. Okay, so two machines are added. We'll see this one is completed. Okay, so here also added, yes, added. So go to the load balancer and try to refresh and go back. Go to backend pool. Still it is showing only one machine. Yeah, okay. You see two VMs are added in the backend pool. Okay, so two machines added. Backend pool is completed. This part is completed. Now, do you think we can able to access the website using this public IP, load balancer IP now? We'll try that also. So copy that load balancer IP. I will search in my browser. Do you think that we'll get a website page? We cannot, because we just simply added the backend pool, but we did not define any rule. Okay, so until unless we configure this rule, the traffic will not be transferred, routed to the backend. So we need to configure the rule, define the rule. Okay, so that is the next one. Until unless you will get page timeout only. Okay, so we'll see now. One more mistake I have did when I create the virtual machine. I will tell what is the mistake. It's not a mistake, just I did to to just for you to get understand. I left that one setting that I will solve after that. Okay, so now I will go to create a rule. So just go back my load balancer, click on load balancing rule. Okay, so before adding the load balancer rule, we will create one health probe. So Health probe, what why it is required? The health probe will be monitoring the backend servers are healthy or unhealthy, everything. It will be sending the signal. Health probe will be sending the signal from load balancers to backend every few seconds. If it is getting a response, then the load balancer will understand, okay, the server is keep running and there is no issue. But if there is no return request, then load balancer will mark the server as unhealthy or fault servers. Okay, that we'll see now. First I'll create a health probe. So health probe name is, just give a health probe name is health VM, and the protocol is TCP protocol. Sorry, the protocol we will give HTTP protocol, and the port we are using the website, right? So the website HTTP port is A0, and the path is root only. Root means www.com, that is the root path. Okay, and the interval is 5 second, which means every 5 second the health probe will be sending the signals. Every 5 second it will send that signal to VM. Okay, if it is getting response, then it will alert to the load balancer server is healthy. That that interval timing we need to mention it. That is the 5 second. Every 5 second the health probe will send the signal. And so let's wait to create the health probe. Okay, health probe is created. So now we'll create a load balancing rule. Why? Because why I have created health probe first. When we create a load balancing rule, it will ask to give the health probe details. Okay. So I'll just go to create a load balancing rule. Okay. So just I will give a rule CLB rule hyphen rule one IP addresses. Here, what is the front end IP? Again, come to the picture. So when we configure this rule, what is the front end IP which is communicating to internet? So front end IP is our load balancer public IP. This is our front facing. So that IP we need to give it. So front end IP is my load balancer IP, and what would be the backend? Backend is my backend pool server. So that you need to choose it here. So adding the rule is rule we define for the routing the traffic. What is the front faced? That is load balancer public IP. What is the backend? That is the backend pool. And the protocol, as I said, the TCP will function. Sorry, load balancer will function on TCP and UDP protocol based. So TCP protocol I am using. And what is the port number? So the front end port is 80. I mean the incoming request, this is the public IP now. So from here public IP port 80. Okay, the whatever request will come, the load balancer will identify whether the incoming request comes in this format or not. Public IP and port 80. So if it is in this format, public IP colon 80, which means public IP is 172.178.32.85 colon port number 80. This is our load balancer IP colon 80 port. If the request comes in this format only, the load balancer will allow. So that is what here the port number. This is front end port and the back end port would be 80. So again the backend, what would be the backend is that is for 80, because we configured web application which is running on HTTP protocol. So that is why we are giving port 80. Okay. So now health probe. What is the health probe for these machines? So that is what I have created on health probe already. So health probe is HTTP and port number is 80. Okay. So next one thing is the important session persistence. Okay, even in interview also frequently they will ask session persistence. Here by default it would be none and client IP and then client IP and then protocol. Okay, so what is a session persistence means? I will explain in the another diagram. Session persistence. Okay, just assume that, sorry, this is my load balancer LB and this is my backend server, sorry, backend pool, and VM 1 2 like this, VM 2. Okay, so when we did not use the session persistence, the traffic will come and it will be equally distributed like this. When we enable the session persistence with this client IP, whatever the request comes to the backend, for example, one request is coming to the backend for the VM1 and I'm getting faster response from the VM1. Okay, and I need a cache also for the VM, which means faster access. So every time when we hit from the internet, the traffic will come load balancer and it will route to the backend. So when we hit the next time, we don't know, the request may go, first time the request will go to VM1 and the next time it may go to VM2. So there is a no guarantee the same request will go back to the VM1. Okay, so if it is changing properly, then there would be some lagging. Okay, so there is then the customer will ask you to keep the machine into session persistence in the load balancer so that the user request, I mean most of the frequent request will go to dedicated machines where they are getting faster response. Okay, so that is the concept in the session persistence. The traffic will go to the dedicated machine for cache, I mean where the caches are there. So if the cache is enabled, the timing will be even more faster than normal. Okay, so that is the purpose. So here if I give client IP, when the first request go to the backend, it will have the record so that the next request also from the same user it will goes to VM1, that is a client IP and client IP and protocol. So based on the request, client IP as well as protocol would be A0. In this combination, the session persistence will work out. Okay. So try to understand what is client IP and then client IP protocol. If you give a client IP, it will just only route to the respective VM only. So we can give the combinations along with the protocol also, that is client IP with protocol. Okay. So you can read the technical word from the Microsoft also. Session persistence specifies the traffic from the client should be handled by the same virtual machines in the backend pool for the duration of session. Okay. So hope you understood about session persistence. I am giving as none. I don't want. And the timed out 4 minutes. So the timed out for the virtual machines timed out. In case if any issue in the VM, we can define the particular timed out during the 4 minutes or 5 minutes. So if you define 5 minutes or 4 minutes, after 4 minutes, the load balancer did not get any response from the VM1, then all the traffic will be routed to only VM2, not VM1. So that timed out. Okay, and rest of the settings are same. Outbound s- source network address translation SNAT. This is by default is recommended. I will tell later about this one. Fine. So I am just saving the rule. So we have created the load balancer rule. Okay. Now come to the picture. Rule is configured. Health probe is configured. Now when I hit this public IP, it has to work out. Okay. Let's see. Let's test it once. Rule is configured. Yes, it's configured. Okay. We need to test it. So go to my browser and just try to hit this load balancer IP. It is not working. It is not working because I have did one mistake. Okay, now I'll tell what is that. So load balancer defined, rule configured, health probe is configured, backend pool configured. We have placed the virtual machine. So inside the virtual machine, the virtual machines we have attached NIC card NSG. Okay, so do you think that we created network security rule for this port 80 for HTTP request? No, we did not created that particular rule. So go to the virtual machine, first VM, go to the networking. You can see in the network security group, is there any rule that is defined for inbound? You see there is no rule for HTTP request. Then how NSG will allow? That is the main use of network security group, right? Over the internet, whatever traffic allowed, network security group also it should be allowed. Otherwise, it will not allow to the virtual machine. So hope everyone understood this one. Until unless we define the rule that the traffic will not be allowed to the respective virtual machine. So for that we need to allow the rule. What I will do, I will create one network security group individually. Then I will add the same network security group to the virtual machine. Okay, so I will create one new network security group. Source group new NSG for LB load balancers. Region is US region. Tags create. So one network security group I am creating, and you see here one network security group. I will place the two VMs inside the one network security group. Okay. I am not giving individual network security group. The existing structure is individual network security groups, but I am giving dedicated network security group for both the machines. Okay. So network security group is created. Go to inbound rule. You see there is no inbound rule. It is there. Okay. I will create now inbound rule. The source is anything. Source IP port is anything, and the destination is any The service is HTTP. Okay. Source can be anything. Source port can be anything. The destination means our virtual machines. Our virtual machine, what is the service? That is HTTP. That is what we needed. So for HTTP, I'm giving us rule 300. Allow HTTP inbound. Yes, just click add it. Okay. So this network security group, I'm going to add in the virtual machines. Let it update. Yes, it is created. Now go to virtual machines. Go to networking. Go to NIC card. Go to network security group. Here I'm adding my new network security group. When I add this network security group, my remote will be disconnected. Someone has to answer this one, why it is disconnected. Okay. Someone should answer for this. After I add this network security group for the VM1, my RDP will be disconnected. Okay. So we'll go to VM2. VM2 also go to NIC card, go to network security group, choosing this new network security group for the both the virtual machines. You see my RDP not functioning after I added new security group. So can anyone say why I'm not able to why I'm not able to take RDP? I'll just show what is the network security group. This is that one. And anyone can say now why I'm not able to take RDP. The answer is here only in the window. Anyone can answer? Okay, fine. So as I said, network security group, I have allowed port A0 HTTP. Okay, so here in the versional diagram also, the network security group level, I have added HTTP port 80. So I am sure that now we can able to access the website over using our public load balancer public IP. You see the magic now. You see, using the load balancer IP, I am able to access the VM1 website. Okay, just I will hit again multiple times. So just copy this. I will open the incognito mode. I will try again the same IP. I need to see whether the traffic is going to VM2 or not. You see the magic, it go to VM2. See, the first attempt I tried, the traffic go to VM1. The next attempt, when I hit the IP, load balancer IP, the traffic goes to VM2. So this is how the load balancer will work out. This is what we discussed. The load will be equally routed to the backend pool. So we configured two VMs, VM1 and VM2. So the traffics are equally distributing to the backend pool. So I'll just give the IP. If anyone in front of the system, please try this IP and check from your side, and please confirm as well. Let's take a 2 minutes of time. If anyone are in front of system, please check this one. So our load balancer configuration is 100% successfully and it is working as we expected. So anyone are trying from your side?
Yeah, I'm able to access.
Okay. So you are able to access VM1 or VM2?
VM1.
Perfect. So do one thing, open your incognito mode and just try the same IP and see what is the what I mean the traffic going to which IP. Sorry, which server.
Okay. VM2.
Okay. It's going to VM2.
Yes.
Okay. So based on the availability, the request will automatically route it. So in case in the server, any one of the server, if I place, if I mark it as stop state, let's see the VM2, I will just power it off. Then the traffic will automatically goes to VM1. So let's wait for stop.
Says service and the line. Yes.
You see my system, after I power off that VM2, the traffic routed to the VM1 only. Okay, so this is how the load balancer will work in the environment, in the Azure environment. So hope everyone clear about load balancer. So please answer so that we'll move for other topics as well. So hope everyone understood about load balancing concept. Okay, so next discussion
Yes.
would be we did not able to take RDP of the VM1 which is having public IP address. Okay, I will power it on the VM1 VM2 again. So I'll go VM1. Though VM1 having public IP, but still I'm not able to take RDP. And you see in the VM1 and VM2, two public IPs are added. One is load balancer IP, another one is our public IP. Okay, so the network security group which I added for these two VMs, you see there is no rule for RDP purpose. Okay, so that is why the VM not able to take RDP even though it is assigned with public IP. Okay, so now what I am going to do through the load balancer, I am going to take RDP, RDP of the server because the load balancer also having front end IP, I mean public IP. So through this, I am going to take RDP. So now what I will do, I will detach the VM1 public IP. Okay. So using load balancer IP, I will take RDP. So quickly go to network interface, go to IP configurations. go to ipconfig. Here I will disassociate public IP address. I don't want two public IP address. One is already assigned from load balancer. Okay, so let it save. Okay, it is saved. So now there is no public IP in the VM1 and VM2 apart from load balancer. So just refresh. You see, after refreshing in the in the details, load balancer IP is configured. Okay. In the topic in the session when we started discussing about communicating of Azure resources from the internet. First one, Azure public IP that we discussed, Azure NAT gateway. Through NAT gateway, we can reach out to internet. Another option is load balancer. So that load balancer we'll see now. So first we need to take RDP of this VM so that we can validate whether internet is working or not. Okay, so this load balancer also kind of NAT gateway. So you all might be knowing what is the use of NAT gateway. With a single IP, then the systems, the servers can be connected to the internet. So the same concept in load balancer also, with the single IP, the internet can be accessible. So before that, first I need to take any one of the VM RDP so that I can see the internet traffic. For that, I need to where is the load balancer? I will go to load balancer. I need to define SNAT rule. Last time we created the same kind of rules in firewall. Okay, so here we need to same thing, we need to define inbound NAT rule. Okay, this is SNAT, source network address translation. Okay, click add here. So you give it as something SNAT rule for RDP. SNAT rule for RDP. Type of the type. What is the type in the backend? Is it for backend pool or it is for the virtual machine? So where you are going to give it. So I'll just give it as Azure Virtual Machine. The target virtual machine, I will give it as VM1. So network of the virtual machine, front end. Front end IP means our load balancer IP. And front end port 3389. I need RDP, right? So that's why I'm giving as 3389. Service tag would be RDP. Backend port would be 3389. Protocol is TCP and ideal timeout as it is. So I will just save this setting. So I gave only VM1. If we choose backend pool, the RDP will be functionable for the entire backend servers. Okay, try to differentiate it, and when you have a time, you practice for all other options as well. So once it is completed, I'll quickly RDP for that one. So this setting, the inbound NAT rule setting for RDP purpose or any other translation related. Last time we seen firewall for translated purpose we seen. Okay, so the same way now using the load balancer IP, I am going to take RDP. We'll see. I guess still RDP will not work because again I did one mistake. We'll see whether it is working or not. 172.178.32.85. Still I'm not able to take RDP. Why? Because in the network security group, I did not enable port 3389, so it will not work out. Go to inbound rule. In the inbound rule, I just only defined for 80, but there is no rule for 3389. Then how it will be translated until we enable the port? Okay, so source is any, destination is any, service would be RDP 33 port 9, 310 is the priority value. So just save this one. So giving access, I'm giving enabling access 3389 in the network security group. So now I am able to take RDP. You can see the logic now. I am able to take RDP. So hope you can understood this point. So please work out so that you will get a hands-on experience as well as hands-on knowledge. So feel I guess it's confusing, but try multiple times so that you can able to. Okay, so now you see I can able to take both machine. So now you see whether internet access is working or not. So just Google internet is not working, but in the command prompt just check IP configuration, or where is that one, you can see. One moment. Okay, so come to the load balancer outbound rule. We did not define any outbound rule so that there is no internet connections inside the VM. You'll see we are getting a error. Okay, so to access internet we have to define outbound rules here. Until unless we cannot access the internet, so go to inbound outbound rule. So just give it as internet rule name and front end IP protocol are everything. Backend pool for my, choose the backend pool and port allocations. This port allocation, so for each and every virtual machines, it will allocate the port for communications. Okay, so when each and every machines will allocate one port so that internet access will be enabled. So I'm just giving maximum number of backend ports and maximum number of ports. So let it save. Okay, cool. So outbound rule is created. You see Google is opening. So after we defined outbound rule, Google is working. You will get the same in both the machine. And you see what is my IP. We are getting load balancer IP. So through this IP, the internet would be accessible now. So if you want to test in VM2 also, I'll just quickly log in. You can refresh the page again, the website page, the load balancer will work out. At the same time, we can use the load balancer for internet outbound connectivity purpose. Come. So Google is working. It is my IP. You see what is my IP? Same load balancer IP. So the single IP used for internet access using the load balancer. This is the one feature from load balancer. Another from to take RDP using SNAT rule, we can take RDP. Using load balancing rule, we can access our website simultaneously. Okay, so yeah, this is all about load balancer. Any doubt in load balancer? So I'm done with the load balancer thoroughly, and you have to keep practicing load balancer. So any doubt in load balancer, guys? So load balancer is completed. Any doubt, guys? Next we'll see about application gateway. So please answer. If all clear, then I'll move for other topic. So I'm going to delete a load balancer. So guys, everyone understood clearly, right? Your confirmation is very much important to me, so that I can start other topic as well. Okay, I guess everyone are understood clearly. So I have deleted my load balancer in the backend. So at the same time, I will delete my virtual machines as well, because we'll create a different virtual machines again for application gateway. Okay, application gateway. Uh, Sorry, in the application gateway, the VM can be added, and there is no uh, mandatory thing that VM must be in the availability set. Availability set is not required for application gateway. Only for the load balancer, availability set is required. Okay, so we'll start a discuss about next thing is application gateway. Okay, so application gateway and load balancer both are similar. Okay, both are similar for routing the traffic equally to the backend. Application gateway also the same, but some good features are added in the application gateway. This application gateway work across globally as well as any environment, on-premises environment or any other cloud environment. If suppose your application is hosted in AWS also, we can use this application gateway. So same concept you see in the diagram. When user hit the consto.com using the application gateway, the traffic will be equally routed to the backend parallelly. There is a one good feature in application gateway, which means Based on the URL, the traffic will be routed. For example, suppose when you give www.microsoft.com/images. When you search the URL in this format, this particular traffic will be routed to some specific servers. And in case if you search something www.microsoft.com/videos, if you search like this, this traffic will be routed to some specific servers. Okay, why? Because they are just segregating the traffic individually. Instead of going to the same server, they are segregating separately. Image server, and this is video server. Okay, and this load balancer act in the layer 7. The layer 7 is completely for web applications. OSI layer 7, application layer. This is okay. So it will work only in the application level. Got it? So now we see about what is application gateway. Application gateway is a web traffic load balancer. It's not a normal load balancer, it's a web traffic load balancer. When you see about Azure load balancer, normal load balancer, it acts as TCP UDP based load balancer, but this is web traffic OSI layer 7 load balancer that enable manage traffic to your web applications. Okay, so the application gateway is mainly designed for web applications, which under layer 7 to route their traffic. And you see the traditional load balancer operate transport layer for UDP TCP based routing mechanism. Okay, and the application gateway can make the decision based on the request, HTTP request. This is what I said here. Microsoft.com/image means it will take the decision. Okay, images, the request is coming images. Okay, immediately will transfer to image server. The request are video, then immediately transfer to video server, like that. HTTP URI path or host headers depends the traffic will be routed. That is what they have explained in this diagram. Okay, so here also same, front end will be there, back end will be the same, but the future are different. Okay, so we'll design it now. I will design the application gateway. Okay, this is application gateway. This is our backend pool. This backend pool, in the load balancer, the backend pool only virtual machines. But in in the application gateway, the backend pool can be virtual machine scale set, or app services, or else on-premises or other cloud services. Okay, this is what I said in the beginning. This application gateway is specially designed for globally. The backend pool can be anything. You can add your other AWS application IP also here, or VMSS, app services or on-prem, on-prem or other cloud. Okay, try to understand this one. Okay, okay, application gateway, backend port, same load balancer, backend port. Now again, as we said, rules we need to define so that it will be work out. So just define this internet. So in application gateway also, public faced, private or both are there. So the incoming request for public IP, sorry, front end IP. This is backend port. Okay. So we need to define a routing rule now. So here, this is routing rule. There we defined load balancing rule. Here the rule is routing rule. Okay, we need to define the routing rule. The request will come to application gateway, from application gateway to routing rule. So before that, there is one mechanism that they have implemented, that is listener. Okay, so the listener, what it will do, the listener will just listen the application gateway, just to see the application gateway, what are the requests are coming from the internet to the listener. Okay, so for example, I'm just from the public IP, I'm hitting HTTP port 80, one application. If I'm hitting the same, then the listener will listen whether the same HTTP port is coming or not. If the listener will match with the incoming request, then the listener will allow to routing rule, will allow to next stage. Next stage is routing rule. Okay, so from here there is one more mechanism, that is backend settings. Backend settings, nothing. In the load balancer we have discussed about session persistence, right? The same concept here, it's backend setting. So the traffic will come from application gateway to listener. Listener will check, and once the listener accept, then it will transfer to routing rule. So rule will check whether respective ports are coming and requests are coming. So the rule will define where you have to transfer backend pool. So in the rule only we have to define where to transfer the rule, backend or applications on premises cloud. We have to define the backend pool in routing rule. So this backend setting just to validate the HTTP setting. The HTTP setting, whatever comes, the backend settings will validate. After the validate, the request will go to backend pool. Okay, just try to understand this one. One moment, guys. Okay, so I hope you understood this logic. The request come from internet using the front-end IP to application gateway. The listener will act as the intermediator, will catch the traffic and will validate whether the request are meeting the expectations. So once the expectation is succeeded and it will route to the routing rule. So routing rule will define where to transfer the request. So we have to define the backend pool in the routing rule. So in between backend setting HTTP validations. Like in the load balancer, we have seen that session persistence for respective servers. So some settings that is there in the backend settings that we'll see in now.
ಕೊಡ್ತೇವೆ ಅಂತ
Okay.
ಅರ್ಥನೇ ಆಗೋದಿಲ್ಲ. ನಮ್ಗೆ ಸುಮ್ಮನೆ ಇಲ್ಲ ತಿಗ ಮುಚ್ಕೊಂಡು ಇದ್ಬಿಡ್ಬೇಕು ನಾವು. ಇಲ್ಲ ಅನ್ಕೊಂಡು ಇಲ್ಲ ಅಂತ ಅಂದ್ಬಿಟ್ಟು ನಮ್ಮನ್ನ ಅಂತ ಫ್ರೆಂಡ್ಶಿಪ್ ಇಲ್ಲ ಅಂದ್ರೆ ಶಾಡೋ ಒಂದು ಐತೆ ಅಂತ ಬಿಟ್ಬಿಡ್ಬೇಕು ನಮ್ಮನ್ನ. ಆನ್ ಫೇಸ್ ಹೇಳ್ಬೇಕು ಮಚ್ಚ. ಇಲ್ಲ ಇಲ್ಲ ಅಂತಾನೆ.
Okay, so I hope you all understood about this application gateway. So we'll go for practical now, creating application gateway. So quickly just search application gateway, go to application gateways, create application gateway. Source group, application gateway name, application hyphen gateway, region, tiers. So there are some tiers in application gateway. Okay. You can say types of application gateway. Some tiers based on the business requirement. The application gateway have designed 4 types of tiers. Okay, the first one is standard, standard. Second one is standard v2, v2. The third one is for WAF, is for WAF2. So WAF means web application firewall, which is specially designed for protecting application against the hackers and attackers. Okay, so standard, in the standard one, you see when I give a standard, the instant count I have to give it as manual. Instance means when the traffic are more, the application will create instance for high availability. So 2 instance means during the high availability the 2 instance will be created for load balancing purpose. So when you give a standard tier, you have to define manually the instance count, 1, 2, 3, like that based on your requirement. When you give standard v2 version 2, then auto scaling came to the picture. So you see when auto scaling is enabled, minimum is 0 and maximum up to 10. So we can define based on our requirement. Okay, so this is in the standard and standard v2. Next one is a WAF. So when you give a WAF, the application gateway comes with standard plus web application firewall by default will be created. Standard and web application. So if we go to WAF2, so WAF2 standard v2 plus one firewall, that is WAF firewall created. So these all for depends on the project requirement. Okay, these are the tier types. So as of now I'm just giving a standard and instance count I'm just giving as 0, sorry, 1. So 1 to 32 is the maximum. So SKU size medium, small, large, depends on our requirement. I'm just giving as medium. So HTTP2, this is the new feature. Usually HTTP is the protocol. If you want advanced protocol HTTP2 also, we can enable that feature. Okay, so I'm just giving disable, I don't want. Next thing, we need to choose the network, on which network we are placing the application gateway. Okay, so here you see we are getting the error because the application gateway would be required dedicated network, dedicated dedicated subnet for application gateway. Here subnet must be in the application gateway. So I'll just manage, click on manage. Need to create a subnet and just place something app gateway app gateway subnet. The range also uh, the range also dedicated for the subnet. So I think 64 or 32 is required. It's 26. Okay, let it create. You see one dedicated subnet for application gateway. Okay, so next is front end IP. Same thing in load balancer also. You see private load balancer, same thing here. Public application gateway, private application gateway, or both. So I'm just giving as public, and here cannot be associated. I will create one new IP for application gateway. App gateway hyphen IP. It is okay. So next, backend. I don't have any backend as of now. I'll just give it as empty configuration. Okay, I'll just simply give it a backend name. Backend. It's not allowing to move next, so it's asking to give something in the backend. So I will give backend pool. Add backend pool without target. Yes, I will add the target later. Okay, so I'll just give it next. So backend, we just created simple backend, and we need to create routing rules now. Okay, so just click on routing rule, or we'll do one thing, we'll just try to complete it, then we'll create it later what it is giving. Okay, so at any cost one rule must be defined so that we can create it. It's not allowing, so I'll just click on create rule name. So rule 1. So I said, right, first we need to configure listener. If you see the diagram, first we need to define the rule. Sorry, define the listener, then rule. Okay. So in the rule, first one is a listener. So listener name I have to give listener 1. Front end protocol. So front end protocol means the application front end IP, that is public, and the port. So I'm designing this application gateway for web application. So the port would be HTTP I'm giving. Okay, and port a listener type. So uh, port listener type for basic and multi sites. For example, I said right, videos, images. So based on that, we can use the port listener type. Okay, if you give basics, you will not see the host name. But if you give a multi-site, I mean, if you give multi-site, it will ask the host name. Host name means something you have to give like http, microsoft.com/images, like that you have to give it. Okay, and then error pages, custom error pages. When you access the application from the internet, if the page is not available, it has to throw some errors like 403, forbidden, 404, page not found, bad gateway 502. So we can define the error here in the listener. Okay, so you see in the listener name, public, front end protocol is public, that is http, front end ip is public, http protocol, and the port would be 880, and the listener would be basic. So listener will match the settings, this defined setting which we are defining now. Okay, so if port is not matching and protocol not matching, then listener will not allow the traffic to the backend. Okay, so listener is completed. Now click on backend target. So here in the backend target, that is, sorry, in the backend setting, I mean in the backend target, uh, we can, these all comes under, sorry, these all comes under backend target. Okay, that we need to define. So backend target, first one is backend pool. So which is the backend pool that we need to give? So already in the second, third tab backend pool, it asked, so I simply gave it as backend pool name. So just gave it as backend pool, and backend, yeah, backend target we gave backend settings. So I said right, backend setting, that I did not define here, so that's why it's giving us empty. So I'll just click it, add new. Okay, so backend settings, I said right, backend setting for validating the incoming request. So I'll just give it as backend setting, and backend protocol is same, http, and port is 80. Here these two are very important one. cookie Cookie based affinity connection draining. Okay, this is very important one in the load, in the application gateway. There in application gateway, session persistence is the important one, but in the application gateway, cookie based affinity and then session connections are draining. Okay, session persistence means in the load balancer, the request will go to the same server. The same way, cookie based affinity also the same. If you see the definition, the application gateway can use cookies to keep a user session on the same server. Okay, if you enable this one, again, I will explain the diagram. This is the server 2, and this is the over the internet. So over the internet, if we enable the cookies based affinity, then the request will go to, suppose when you hit the first time, the request go to VM1. If you enable the cookie based, then the second time also it will goes to the same one. To keep the user in active state, the request will go to the same VM only for high availability. Okay, that is cookie based affinity. The next one is connection draining. So connection draining, what it will do, uh, we can define the request timed out also here. 20 minutes here we have defined, right? So we'll take the example of this 20 minutes of timed out error, timed out. Okay, So 20 minutes time is there. So when we enable the connection draining, so for example, uh, this VM 10 users are in active state, which means 10 users are keep connected to the VM1, and the VM2 also 10 users. Okay, so that connection timeout I have given as 20. The connection timeout, sorry, connection timeout, you ignore it. So if you give a connection draining time, for example 10 minutes, see 10 minutes, I think it is in the seconds. Okay, seconds. Okay, we can convert the minutes into seconds. Assume that 10 minutes of time. So for due to maintenance, so each server would be having some maintenance. So for the maintenance, I'm enabling connections draining. So during the connections draining, the servers will not affect and the business will not go down. Okay. So suppose I gave 10 minutes connection draining, the 10 active users are there. So it will not allow the load balance, sorry, the application gateway will not allow any new request, to this particular VM. 10 minutes means 10 or 20 whatever. During that time, the application gateway will not route the traffic to the VM. Okay, and during the 10 minutes of time, the users whoever connected, 10 users whoever connected, the the users will be slowly migrated to the VM2. The connections will automatically routed to the VM2 during this particular 10 minutes of time. So in case in this 10 minutes only 5 users staying here and other 5 users went to the VM2, but still 15 users, now 15 users in VM2, but 5 users left out, but the time is about to end. What will happen? So the connection draining will just disconnect this entire 5 user sessions, and when users will access next time, the access will go to VM2. This is the concept for connection draining time. You can give it in the seconds. So during that seconds, the draining will happen and the request will transfer to other VMs. Okay, so hope you understood about this session and cookie concept. Okay, you see the connection draining technical definition. Connection draining help gracefully remove backend pool members during the planned service update. When this feature is enabled, re-registering instance of the backend pool won't receive new request. This applied to the backend instance that is explicitly removed from backend pool via API. Okay, so this is the definition. You can see it later. And then override backend path. Okay, so you see this is what we discussed in the, where is the session? Yeah, here host based routing in the application gateway. That is what they have defined here. If we give the host name, then the traffic will be routed to the respective host name. Okay, so as of now I'm not going to give anything. I'll just keep it as it is. Okay, just click add. So backend setting is added. So just see in the picture, backend settings is completed, listener completed. So click add it, click next, review and create it. So any doubt till now, guys? So any doubt, you can clarify your doubts now. Okay. Load. Oh, it is getting failed. Three resources of public IP address. Okay. So there is some issue with my public IP address, which is I have some public IP address already, so that is why I'm not able to. So I just quickly release some IP addresses. Guys, any doubt till now regarding application gateway and load balancer? It will be little confusing because both are similar concept, but when you practice multiple time, you will get a real scenario of application gateway as well as load balancer. Okay. So once this is completed, I will quickly create two virtual machines. Okay, let it create. So any doubt till now? Till now about this load balancer application gateway? So listener, backend target, setting. So very simple. One front end IP for application gateway and one backend pool. In the backend pool, uh, we need to define the routing rules. To create the route rules, three parameters are there. First one is listener, backend target, and backend setting or HTTP setting. Okay, so let it be. So let it create. It's creating. Oh, set bad request. Okay, so the application tier which is deprecated. So I'll just go for redeploy, recreate. Okay, the standard version already deprecated from Microsoft. So quickly I will freeze it. Reset application. Quickly I will create load balancer application gateway. Standard V2. I don't want a scaling, so instead will be one. Disabled network, load balancer, application gateway, front end, P. And just to see what I'm doing, guys, I'm just recreating the load application gateway because the first one was, I mean, standard version was deprecated, so I'm just creating in a standard V2. So getting role priority 100. Priority, sorry, I forgot. Priority we need to give rule priority 100. Listener listener 1, front end IP public port same. So backend target, backend pool, backend HTTP setting that we need to give. HTTP setting. Cookies all are off, disable. Um, request time rate for the server. Request time rate for the all the servers back in the backend. When the server is not unhealthy, then we'll get a request time dot error for 20 seconds. Okay, so backend target is completed. Fine. So click add. Something is missing. What is the error? Everything I gave. Okay. So next. Let it create. So to add the backend pool, I'm creating a servers. Okay. So the backend pool can be few. One is virtual machine scale set, application services, app services, on-premises network or other cloud. So I am just creating virtual machine and putting into backend. VM1 set none trusted. And this VM does not require availability set. Port public IP the network security group. I have already one security group which we used for before load balancer, so I'm just giving the same security group. Okay, so application gateway is getting created. Make it complete. Create application gateway. So any doubt guys in the application gateway? I hope all the points are thoroughly we discussed. So once application gateway deployed, then we'll quickly see the example. So guys, do we need two VMs for testing purpose or one is enough?
One should be fine.
Okay, fine. Uh, because if two VMs again we need to configure same web services again. So one VM means quickly we can finish it out. So let's complete it. So in this in the VM backend pool VM, in the backend pool we are choosing VM. So in the VM, how in the listener we defined port 80 and the rule also we defined port 80, backend settings also HTTP settings 80. Same way here in the backend pool VM we need to enable HTTP and make it as port 80. For that we need to create web server. I mean we need to convert the VM into web server. IIS needs to be enabled. Okay, that's we are going to do now. Okay, VM is completed. Come down. What is the public IP? So we'll enable SS ES in the same server. So go to server manager. Let's write complete. Okay, load balance. Sorry, application gateway is created. Yes. Okay, deployment is completed. Application gateway. So the rules also we have defined. So let's see the rules is clear. You see, the application gateway version what we gave is standard V2. So standard V2 means auto scaling function will come, but WAF will not come. Firewall, web application firewall. You see, when I click on web application firewall, it is showing as upgrade to other tier VF2. If I upgrade, then web application firewall also can be configured in the application gateway. And here my front end IP is this one. This is my application gateway front end IP. Okay, and it is located in this subnet. So when you go to IP configuration settings, you can see public IP which is configured and rule also configured, and private IP we did not configure it. Okay, go to backend pools. You see there is backend pool, but we did not added any of the machine in the backend pool. Okay, so let's complete this configuration and then we'll add into backend pool. Add this, next, install. So in the backend pool, click on the backend pool, just edit it. Here you see the target. What are the target can be associated in the backend pool? The first one is IP address or the FQDN. This is for on-premises or other cloud. Another one is for virtual machine scale set, app services. These are the possibilities could be in the backend pool. So I am giving a virtual machine because mine is virtual machine. So choose the virtual machine IP. Okay, so just save this one. So backend pool, we have added the virtual machine which we created. You can validate the backend settings which we created. HTTP backend settings. Backend port is 80. Connection drain and cookie is not enabled. Requested time dot is 20. And I did not give any URI path. I mean URL based routing. So as of now, I just give it as no only in the backend settings, and then front end IP configurations. Already public IP it is added in the front end. Okay, so let's wait to complete. So in the configuration tab, we'll get auto scaling, instance count, HTTP settings, web tier settings, standard or standard V2, whichever required. We can upgrade the application gateway, that is in the configuration tab. Based on our requirement, we can increase the instance count. Okay, so these are the few settings are important. In the settings, configuration, web application firewall, backend pool, and backend settings, IP configuration settings. These are the important. And listeners. You see the listener which we created. This is the listener. Port is just click on that and it will open. Listener setting. Listener 1, front end IP, protocol, HTTP, port is 80, and listener type is basic. So listener matches means then it will route to the rules. So rules is backend rule. Inside the backend rule, we define the backend settings also. You see the backend rule, listener is we attached this listener, and backend target we have added the backend pool as well as HTTP settings. Okay, this is what you need to verify it. Certificate based SSL setting is there now. Certificate based authentication also is there in the web application. Okay, that when you have a time you can just go through YouTube's and get it some knowledge about SSL settings. Okay, so same when we did point to site VPN certificate generated and authenticated with the certificate, right? Like that, using SSL certificate we can add extra security for our application. Okay, so fine, see here it is configured, IIS is configured. We'll try to hit the application gateway IP now. So go here, it should go to web services. You see the application gateway is routing to our web server. So you can just edit it now. Just edit it here. Web server. Go here and refresh. See the web server is came to the picture. Okay, so application gateway is working successfully, and our experiment also successfully done.